Hello everyone. Today we are going to see the last section of module 5, that is collection of particulate pollutants. Collection of particulate pollutants. Particulate matter is a sum of all solid and liquid particles suspended in air, many of which are hazardous. This complex mixture includes both organic and inorganic particles such as dust, pollen, smoke, and liquid droplets, that is aerosol. Today, we are going to see how we are going to collect the particulate pollutants. It is generally grouped into two types of particulate pollutants. First one, they settle out due to force of gravity, and another one is suspended as aerosols, that is liquid droplets. The first category consists of large particles. Its size are most greater than 10 micrometer, that is the diameter of the size. And we can collect that material by using sedimentation technique. And the second category, the particle size is smaller size, is more sophisticated method used to settle it, like filtration, enrichment, electrostatic precipitator, etc. are used. Most instruments' function is to collect the pollutants, and analysis of weight is done separately. Sample collector. There are two different collectors are there to collect the gaseous pollutants and to collect particulate matter. The gaseous pollutants and the sedimentation and high volume particulate matter collection are already discussed in last section. In this section, today's section, we are going to see tape sampler, impingement, electrostatic precipitation, and thermal precipitation. Tape sampler. Another popular method of sampling is another name is soil haze particle sampler or beta gauge, because it looks like a reel-to-reel tape recorder. In this method, a known volume of air passed through a paper tape. That paper tape is in the stationary position, or tape is held stationary, and sampling air will pass through a nozzle, and these particulates are collected on the paper tape, forming a spot. The sampling time could be varied from as little as 10 minutes per sample to 2 hours, depending upon the amount of particulates. Spots are evaluated by analyzing the amount of light that can be transmitted through the spot. The measurement is reported COH per 1,000 feet. The tape sampler, the measurement is reported COH per 1,000 feet, not CHO, COH. That means coefficient of optical haze. The interpreting of COH values, there are different guidelines are there, that the interpretation of COH index is discussed in the next slide. Then the spots, that the pollutant situated in that after the air sampling, the pollutants are going to collect in that the surface of the tape, that is known as spots. The spots obtained are evaluated by analyzing the amount of light that can be transmitted through the spot. In tape sampler, we are going to find out coefficient of optical haze. Equation for find out the COH, that is COH divided by 1,000 feet is equal to log T0 divided by T into A by V into 10 raised to 5. T0 is transmittance of clean tape, that is 100% clean tape. T means the percentage of light transmitted through the spot. That means after the test, the transmittance percentage, the percentage of light. A is the area of the spot in the square feet. V is the volume of the sample in cubic feet, or the product of the average sample flow and sampling time. This is the equation to find out the COH value. If the COH index, that value lies in between 0 to 0.9, we can say that the degree of pollution is very less or light. The value is 4 to 4.9. We can say that that air is a polluted air, extremely heavy polluted air. A more realistic analysis of spot is based upon beta ray attenuation. Here a beam of beta ray particles of constant source with intensity I0 is passed through a tape. By measuring the intensities IC and IP of the radiation that has passed through a clean tape and through the spot, respectively, the mass mu p of the particulate matter per unit area of the spot can be evaluated by an equation. Mu p is equal to 1 by k log IC by IP. Here k is the constant which depends on the energy of the beta particles. The intensity of radiation can be measured by Geiger counter. The mass concentration of the particulates in the air, rho p, is given by rho p is equal to mu p into A by V. Mu p is the particulate matter per unit area of the spot, that is calculated in the previous equation, and A is the area of the spot, V is the volume of the sample. Next method of air sampling, that is impingement. Air sampling means we are going to collect the air samples for monitoring and further analysis. So the method of collection of air sample, that is one of the method is impingement. In this method we are going to separate the particulates from the air by the help of collision method. This collision method or impingement method, we are going to provide different obstacles inside this container. This particulate collide with this obstacle, and after this collision the air changes its direction. If this collide obstacles are dry surface, the obstacle surface is a dry, that is known as a dry impingement, and if the obstacle is wet by any liquid, then it is called a wet impingement. There are two types of impingers are there, dry impinger and wet impinger. In this, dry impingers are not efficient to collect the size of particles is less than 2 micrometer. The advantage of this one, this dry impingers, there is no need of filtration and evaporation in liquid. The certain dry impingers called Cascade Impactor or impinger, making particle size measurement. This Cascade consists of 5 to 10 collection stages in which the sample airstream is constrained to pass through a series of jets where particles are directed against the collection surfaces placed normal to the jets. The smaller particles having lower momentum are collected in later stages, where the jet velocities become progressively higher. In most of the Cascade impactor, a filter is placed after the last stage to collect any fine particles that might have passed through the impactor. The next slide can see a systematic diagram of a Cascade impactor. After sampling, the material collected at each stages is analyzed for its weight and chemical composition. The impactor is mainly used to collect the particle size ranges from 0.2 micrometer to 0.06 micrometer. the next method of air sampling, that is electrostatic precipitation. Electrostatic precipitator is a filtration device that removes the fine particles like dust, smoke, or this pollutant particles from the gas using the force of an induced electrostatic charge. That is the theory behind this electrostatic precipitator. Let us see in detail about this electrostatic precipitation with the help of a figure that is inserted in the next slide. Working principle of electrostatic precipitator. It consists of two sets of electrodes, positive and negative. The negative electrodes are in the form of wire mesh and the positive electrodes are in the form of plates. These electrodes are vertically placed and are alternative to each other. The negative terminal of high voltage DC source is used to connect the negative electrodes and the positive terminal of the DC source is used to connect the positive plate. To ionize the medium between the negative and the positive electrode, a certain distance is maintained between the positive and negative electrode and the DC source, resulting in high voltage gradient. The medium that is used between the two electrodes is air. If this conductor that is surrounding by air, that is known as corona discharge. The corona discharge is an electrical discharge brought on by the ionization of a fluid such as air surrounding a conductor that is electrically charged. Here, two electrodes are surrounded by air. So that is known as corona discharge. The corona discharge around the electrodes or the wire mesh due to high negativity of negative charges. The entire system is enclosed in a metallic container consisting of an inlet for flue gases, that is incoming gases, and an outlet for filtered gases or outgoing gases. There are plenty of free electrons in this chamber or in this electrostatic precipitator. Electrodes are ionized, which interact with the dust particles of the gas and making them negatively charged. These particles move towards positive electrodes. It is attracted with positive electrodes and fall off due to gravitational force. Now, the incoming gases is free from the dust particles. That incoming gas is known as flue gas, that is free from dust particles as it flows through the electrostatic precipitator and the discharge to the atmosphere through the chimney. This is the theory behind this electrostatic precipitator. Thermal precipitation. This thermal precipitator consists of two surfaces with a high temperature gradient in between these two surfaces. The smaller particles have a tendency to move towards the lower temperature and get deposited on the colder of these two surfaces. These temperature gradient are normally of the order of 3000 degrees Celsius per centimeter. The collection efficiency of thermal precipitator are quite high for smaller particles. That is, the particles range from 10 micrometer down to 0.01 micrometer. The particles are collected on a grid or thin microscope cover glass for later analysis.